general tasks. And sometimes I end up on a side quest that leads to like wine commit, mono commit, mesa commit. So today I want to talk about all the complexities around Proton and what makes Proton a Proton and how to maybe approach making a minimal version of it that's less daunting and has less of the inherent complexity. So first, let's start with what is actually Proton. So I like to think it as a downstream wine distribution that packages a lot of things that you have to assemble yourself otherwise. So because wine by default doesn't come with all the batteries included, it has a lot of things implemented, but we have native DirectX implementations that we provide. There's a lot of custom fonts patched for metric compatibility, so they render correctly. There's our libraries for speech synthesis and speech recognition that are very hard to package in distributions otherwise, because they're just developed weirdly. And as far as I know, some of those are not packaged in most distributions. And then we have some custom bits, which is the important part. So there's a lot of wine patches that are developed on Proton and for Proton at first. So there's about 2,000 patches on top of wine upstream right now. 500 of them are marked as upstream cherry picks, which is good. I think there's more that just are not denoted as such. And there's other things that we bring in, like the alternative sync implementation. So we have eSync, we have fsync, there's a bunch of patches from wine staging, there's a bunch of hacks that are not upstreamable, and there are just things that are staging in Proton and will eventually, hopefully, get upstreamed. There are also things that help us integrate with Steam a little bit better. There's a Steam API bridge. Its role is to map the whatever is called on the Windows side to the Steam API that the Linux version of Steam exposes. There's also Steam Exitium, more a little bit on that later. And all of that is meant to run inside of Proton runtime. You can think of it as like a container. There's also a little bit more details on that later. So what would a hypothetical minimal Proton be? So it has to run at least some games. It has to have Steam API integration, so that's the basic. It has to be launchable by Steam, via Steam, so you have to be able to select it as a compatibility tool, click play on your game, and it runs. As close to upstream wine, so drop all the custom patches, drop all the new sync implementations, just have the Steam integration in. No Proton build system involved, because Proton builds so many different projects, it's a build system of build systems. So it's getting a little bit complex, and sometimes it's a little bit hard to like start working on Proton from this angle. And we're working on improving it, but yeah, it's slow. And also we'll try to skip all the runtimes. So you run on your native host OS without anything in between. So let's start stripping things down. I started fresh. I just took a wine 10.15.3 and started applying things there. And we used wine build system. So first we had to think what we wanted to bring in. The Steam Exitium is something that pretends it's actually a Windows Steam run. Some games look at the process tree and see, oh, I'm not a descendant on Steam, so something is up, I'll refuse to run. There's a lot of games requiring that, but not everything, so I decided to skip it. There are a few niceties, like some registry entries are populated by this thing. There's like a flag that you can set environmental viable, and it stops before actually executing the game, so you can attach early. But for most games, it's not necessary. So this one we'll skip. But what we're going to bring in is lsteam client.dll. So this is our implementation of the Steam API. It's built using modified makedep, which is a part of wine build system, and this is what generates most of the actual make file. So we had to have some changes done to it, but and it's a directory on a top level of Proton source tree. So it's outside of wine, so we had to modify makedep to build something out of tree. It calls into the Linux version of Steam Client. It's mostly auto-generated using the provided source code from Valve for their SDK. And it does some extra things than just like simple call conversion. There's like Linux paths converted to Windows paths and vice versa. So we had to do that. We're going to bring this in, and we're just going to copy it into DLL's directory, add it to the configure AC, and hope that it's going to work. Then the next thing is wine patches. As I mentioned, there are 2,000 of them, but to have the very basic Steam integration working on Wine 3-based Proton build, we need only 4 of them. There's a lot of niceties missing from that, like Steam Cloud won't work properly because of usernames, a lot of other things won't work. We won't have the XVK integrations or VR client integrations, but just to run a game, that's enough. And those patches are quite simple. So the first one is to allow building with C++ sources. That's a make the patch. Since a lot of the Steam client stuff is C++, we just require that. The next thing is to set up the trampolines to the Steam client. So we don't actually replace the Steam client.dll with our version because some games check it. And that's a very common pattern that, oh yeah, there's a DLL that's not signed by Valve, so it looks suspicious. So instead, Valve provides with Steam Linux installation the signed Windows versions. And we just do some magic in anti-DLL to whenever it's getting called into, we actually generate fault, and then it jumps into our own implementation. So that patch was required. Then there's another hack that's required by a lot of games and the Steam API integration. So there's a registry value that has process ID of running Steam instance, and that's expecting this Linux Steam instance, Windows Steam instance. Since we don't have that at all, we need to substitute it for something, and we just substitute it for the current process. It's a hacky thing to do because the games don't actually check if it's a Steam. Just they check if it's an existing process and if Steam is running. So that's that's enough. And there's just a bunch of registries that games like to check, registry entries that games like to check that they that we need to provide. So with those 4 patches, we have Wine already building, and we have Wine with Steam client. Now the question is, how do we run it inside of Steam? Steam launches Proton by a Proton helper script, which is written in Python, and it's a very large, like around 2,000 lines of code script that applies a lot of workarounds, sets up a lot of environment variables, sets up a lot of paths. And we don't really need most of that complexity, so we're going to be replacing it with a simple shell script. It deals with capturing logging, starting Steam through the Steam execution, setups you with your first prefix on the first launch, and to speed things up, instead of letting Wine to set up new prefix, it copies something that's created on the build time, and yeah, we're just going to use the Wine logic for all of that. So the replacement, instead of 2,000 lines of code, is basically this. So we set Wine prefix based on the Steam compat data path that Steam provides for us. We need to copy those to Steam client DLLs to the paths that are expected by the games, and then we just need to handle one of the verbs. So you have Proton, then a verb, and then what you want to do. There are a few of them, but the one that matters for running things is wait for exit and run. The name means that you wait first for like any previous instances of Wine running in that prefix to exit before you actually run something, but we just skip all the complexity and we just run Wine directly. So now let's talk a little bit about Steam runtime. So we have Wine, we have Proton script, but how we actually run that inside of Steam and how the runtimes are picked up and how we can skip them. So Proton is built to run inside of runtime. This is based on something called pressure vessel. You can think about it like Flatpak Lite because it reuses bits of Flatpak, but there's a huge difference that you don't have to bring your own graphic stack. Because with Flatpak, every single application there has the full graphic stack, Mesa or NVIDIA blobs included. This is smart enough to check your host OS, bring the current version of the graphics drivers you have installed there, bring it into the container, check things against ABI guarantees that there are like files defining those, and then run Proton inside of this. So this is a Valve project, but there's a community-run project called Open Wine Components and specifically UMU Launcher. that allows you to reuse the same exact thing outside of Steam. And Heroic is using that. I think there's work ongoing or either ongoing or completed to use that also in Lotris. So that's also making its appearances elsewhere. So we have container images to build Proton to target that particular runtime, but yeah. So why we run things in runtime? Because things are complex when it comes to a lot of the distributions out there. So distributions like to put things in different directories. They like to break API compatibilities on the user space side. It's not really well maintained. So kernel API, rock solid. User space API on Linux, kind of nightmare. And that's the reason for it. There's also full design docs available if you're interested, like in how it works and why it was designed as well. This way, but we are going to skip all of that. So one thing you have to put along your Proton file is a VDF, which is like a Valve's format that they use. It's JSON-ish like to specify things, and you need to tell it what you are, how you are supposed to be run, so command line Proton verb, and require tool app ID. This tells us require this tool app and layer us on top of it. So that's the number here is Sniper. So that's the current generation of the runtime. What we can do is we can skip it. If you omit that line, you just run directly on the OS. Is it mandatory for good experience and getting any help? Yes. For tinkering and trying things out, not really. But yeah, if you ever try this out, please don't submit any bugs. We're not going to support you. So there's also another runtime, because like, why can you have, like, if you can have one runtime, why not having two runtimes, right? So Steam itself runs into a runtime, and then like we inherit that environment, and then everything inside of like Proton and Deeper runs inside of that second level runtime. But this like top level runtime is the simpler older generation one that uses only LDA library path. You can skip it. That means that usually Steam won't start on your system out of the box. You need to install many lib32 libraries to make it work at all. And you can skip it, but I haven't done that in most of my testing, and it works well because it still brings most of the host libraries in. So this might disappear at any time. It's extremely not supported. Then we need the last bit of configuration. This is just a file that Proton generates during the build process, and it's to tell Steam what kind of compatibility tool we are. We just said that we map from Windows to Linux, so run Windows software on Linux, how it should be named. There's some special handling based on the tool name and display name. It has to include Proton for Steam to consider you a fully fledged Proton and have everything working. But you just put that along with the Proton script, and then you can drop everything in Steam compatibility tools. So I've actually done all of that, and source code is available. And it's Wine 10.15 with a dozen or so patches. So those are the 4 patches that I mentioned before. Then there are patches bringing in LSteam client and doing some of Freebase fix-ups. So those are fix-ups and not actual like working changes. Then there's a mini Proton directory inside of it that allows you to like explains how to run it. And since we have still a lot of time, I can actually show you how it works. So this is just Linux Steam. I have selected mini Proton as the compatibility layer. I'm running Deltarune t-shirt, so Undertale seemed like a sensible pick. Let's see. If Steam wants to cooperate, sometimes it's not very.
Can you close settings? Do you have to close the window?
It should work without it. It worked in previous testing, but that is
the way go back.
no, it's broken. And that's like not even us. It's just like Steam doesn't do anything.
On the game list, right click and Remove the computer.
Steam is broken, just a second.
Feel it harder.
If you know switch that works better than the Jazz Dash 9, then please let me know because sometimes there are things I need to kill harder. Steam update
I'm not taking 211.
since today's morning.
And this is the uploaded record.
Yes. It worked when I was sitting just like back there, so the stage is really cursed. Okay. So we should see yeah, wine prefix update because it's just upstream wine. In Proton we hide that from the users. They never should see that. And now just runs Undertale. And if we look at the process tree, you can see that there's, I'm not sure how, oh yeah, that's readable. So you have Python 3 wine path, but that doesn't matter. So Steam, Reaper, and everything in here is just wine process directly. If we look at this thing, this is running Steam Web Helper. So those are the CEF processes that running like the browser integrated in Steam. They're running inside of the runtime, but the wine part completely skipped it. So it's running on bare metal. It's running basically upstream wine with a few patches, and Undertale uses Steam API, and it works, and it's closed into Steam and syssteam, and it's considered like all up and running. Any questions? Yes?
Can notes in library be represented in C? Because I think it's like mostly common stuff. I think
What can be rewritten in C?
Austin line.
Probably, but why? Like I don't like it's auto-generated using Leap's Clang into whatever we have right now, and there are just a few things that that are necessary to be hand-woven to have this path conversion. And I don't really see a point of exercise of trying to be pure about C in this particular case. The Steam thing itself is the Steam API is C++ by itself and just makes it easier to call into that on the Linux side. So it's probably possible, but I don't think it's worth the time investment. Are there API issues with it being C++? So far, so good. Everything that was not working, it was usually like self-inflicted, as in we messed up some conversion somewhere, or one of our hand-woven wrappers was not quite correct. All the auto-generated stuff and just calling into the C++ side of Steam client just worked.
I mean there are two different C++
There is, yes, there are multiple C++ APIs, but yeah, that haven't been an issue in terms of Steam client. Yep. Any other questions? Yes.
I wonder if it's possible to make it work on macOS.
Is it possible to make this work on macOS? So I think that team has done some investigation relating to making something like this work. There are some bits that Valve has left for macOS, like for compatibility tools on the Max version of Steam, but I don't think it's fully working. So I don't think that like Steam has the necessary integrations anymore on the macOS side.
7 years ago, with the right settings, you could get macOS Steam to launch something like that.
Yes.
That was 7 years ago.
Yeah, 7 years that was working. I think team did some experimentation regarding that like 2-ish years ago, and most of those most of the code responsible for compatibility tools was stripped out. So there are still some leftovers. It can read some of the values, but it's not fully working. Yep. Okay, that's it. Then that's the presentation. I'll share the slides and links to everything, like on the mailing list, and the code for that version of mini Proton is public.
Thanks so much.